Hello all, in this particular tutorial we will learn about Oracle 19c Wallet, TDE and RMAN backup encryption. TDE stands for Transparent Data Encryption and we are going to see this particular tutorial using Administer Key Management. Now, I would like to give you a warning before you proceed. Stop before you proceed. There is no way to recover encrypted data if wallet or its password is lost. Remember this, there is no way to recover encrypted data if the wallet or its password is lost. Now that we have understood the warning, let's go ahead and see the procedure. So we need to set set two instance level init parameters. One is the wallet root and another one is TDE configuration. The wallet root parameter has to be set at the SP file level and hence we need to bounce or restart the database. Once we have set these particular parameters, we can create our wallet, and to do that we will be using administer key management SQL plus command. So first step is create a password protected key store, software key store. Then we'll be opening the password protected software key store. Then we'll be creating and activating a master encryption key. And finally, we will be setting the key store to auto login. So the steps are create, open, create and activate master encryption key and set key store to auto login. Now that we have seen these steps, let's see these steps in detail. So the first part is setting the instance initialization parameters. The two parameters we talked about are wallet root. Wallet root is the location where your wallet will be stored. So make sure you create this directory, and scope will be at the SP file level. And then we will shut the database, start up the database, and we'll set another parameter called TDE configuration, where we'll say key store configuration is equal to file. Now, once this particular parameters are set, we are ready to create our wallet. So to do that, we'll use the administer key management, create key store, location of our key store, password of our key store. Once the key store is created, we will say set key store open. So we'll open the key store. Then we'll create and activate the master key. So set key. And finally, we'll create a key store to auto login, saying create auto login key store. So create key store, open key store, set the key, create auto login key store. Now, once we have done these steps, what we can do using TDE? So we can create a table with encrypted column. We can encrypt existing column. We can create encrypted tablespace where all the data files will be encrypted. We can convert existing non-encrypted tablespace to encrypted tablespace. We can move a table from unencrypted tablespace to encrypted tablespace. We can enable RMAN backup encryption. So literally there are other functionalities which I have not covered, but these are some of the functionalities that we can achieve after setting our wallet. Now, let's understand, if you want to create a table with encrypted column, you will use the same syntax of create table, except whichever column you want to. So let's say you want to encrypt this column C2, then you will say encrypt using the encryption algorithm. There are other algorithms. I'm using here AES-256. If you want to convert an existing table column to be encrypted, you can use the modify clause, column name, encrypt using AES-256, no salt. Now here I have not specified the no salt, but here I am specifying the no salt. So it is not mandatory, you can skip this, but basically salt is a random string added to data before encryption, is a way to strengthen the security of encrypted data. I would like you to read about what is this salt parameter and what it does. Now, let's say if you want to create an encrypted tablespace, you will use the same syntax of how you normally create, except for you will add additional cost, encryption using the algorithm encrypt. Now, if you want to convert a non-encrypted tablespace to encrypted, you will use the alter tablespace users, again the same clause. If you want to move a table from now that, let's say if you want to move a particular table, which is this particular table is in the non-encrypted tablespace, and you want to move it to an encrypted, you will use the alter tablespace, name of the table, move tablespace, and the name of the encrypted tablespace. If you want to enable the RMAN backup encryption, you will use configure encryption for database on. So this is the RMAN level configuration parameter. You will change it to configure encryption for database to on. Now, some of the queries that you might be interested in, if you want to know about your wallet, you can use $encryption wallet. If you want to know about your encryption keys, you can use $V encryption keys. If you want to find out if a particular tablespace is encrypted, you can use the encrypted column from DBA tablespace. If you want to know if your backup is encrypted, RMAN backup, you can use the encrypted column from the $V backup page. And if you want to know the encrypted columns in the database, you can use the DBA encrypted columns. So these are all the queries. These are some of the important dictionary views that you can use to actually query about your encryption. Now, there are other tools used to manage wallets and certificates such as Aura PKI, MKStore, and Administer Key Management. Aura PKI is a command line Oracle utility that you can use to create wallets and then add and manage certificates, certificate request, and certificate revocation list in wallet. So this is another utility. MKStore is also another command line Oracle utility that you can use to add secrets and credentials to wallet and then manage them. It is available in Oracle Database Client. Starting in Oracle Database Release 23 AI, MKStore is deprecated. Oracle recommends that you use Aura PKI instead of MKStore. Administer Key Management statement provides SQL plus interface to manage transparent data encryption key store. So these are and remember, this tutorial is based on Administer Key Management. I have not used Aura PKI, neither I have used MKStore. So everything that I have done here is using the Administer Key Management. Now, whatever functionality I have done here, you could have done it using Aura PKI or MKStore, but we are going to stick to Administer Key Management in this particular tutorial. Now, this is the some of the things that I would like to highlight. So wallet location, where you can store your wallet location. You can store your wallet location information based on the two instance initial parameters wallet root and TDE configuration, or you can use the SQLnet.aura parameter called wallet location, or you can use the SQL.not.aura parameter called encryption wallet location, or the Oracle database will derive the location based on the database environmental variables Oracle base or Oracle home. The search order of the location for the wallet is based on how you have set this. So the search order depends on whether you have set the instance initial parameter, SQL.aura, or environmental variable. Let's understand this in a detail. So Oracle database retrieves key store by searching this location in following order. So the first, it will look for this, followed by this, followed by this, followed by this. So this is the search order. Let's understand this. So if you have set the wallet root and TDE configuration, then it will look for these two parameters. Oracle recommends that you use this parameter to configure key store location. So this is the recommended way of setting the location for your wallet. If we are not going to use this, then we can use the wallet location setting in SQLnet.aura. If you are not going to use that, then we can use another parameter called encryption wallet location in SQLnet.aura. This parameter is now deprecated, and if none of this is set, then based on it will try to search the wallet based on Oracle base or Oracle home whether it is set. So these are the locations. Now that we have understood everything, let's go ahead and connect to our database. So to do that, let me launch the SQL developer. No, not this. Give it a minute. Yeah, and let me connect to the database. Yeah. So now the two things, first what we will check is we will check whether we have got the wallet or encryption keys. So you can see here by default this is the Oracle base location. This is the Oracle base. So it is looking for, so none of this is been set. So none of this has been set. So it's looking for the key store location based on the Oracle base. So none of this has been set. So it's going for this. So this is the default location where it's looking for the wallet. And now the status is not available, which means there is no wallet in this location. Let's take a look at our encryption keys. And that also looks blank. So there are no encryption keys. That is, the wallet location is based on the Oracle base, but it is not available. Now let's connect to our Oracle session. Let me put it in the center. clear the screen. And the first thing that we are going to do is we are going to create a directory where we are going to store our wallet. So the brand new directory has been created. Let's go to that directory. Let's check what's there in that directory. Obviously nothing, because we just created that particular blank directory. So we don't have anything in that particular directory. Now, the first thing that we need to do, as I mentioned, we need to set two instance initialization parameters. So wallet root and TDE configuration. Let's do that. And one of the parameter needs the bounds. So let's connect to the database. Before connecting to the database, we need to set the environmental variable. That's done. And let's connect to the database. And this is the first parameter that we are going to set. Alter system wallet root. Let me do something. Let me clear the screen. This is the first parameter. Alter system set wallet root location of your wallet. So this is the directory that we have already created. Scope is equal to SP file. Once that is done, we will bounce our database, because this particular parameter we can only change in the SP file level. So the database is getting shut down, and I've given both the commands in sequence, which means after shutdown, it's going to start again. The instance has opened successfully, and now we are going to set the second parameter. Let me clear the screen, and let's set the second parameter, which is a TDE configuration, and the key store configuration is equal to file. Now here, if you notice this, this was the location that it was trying to look for the wallet. But now that we have set the location as home Oracle wallet, let's see what it shows. And you can see home Oracle wallet TDE. So it has taken this TDE as an extension. By default, it is taking this extension, and encryption keys are still not there. And this wallet is also not there. There is status is not available. And the reason for that is pretty simple. Let me open another session. Clear CD. I wanted to go to this location, not that. And you can see this particular directory is completely empty. So now that we have set the instance initialization parameters, we are now ready to create, open, create and master encryption key, and auto login. So we are going to do all of these 4 steps. So let's do that. I'll open another. Yeah. And now let's see if we have encryption keys, and let's check our status of the wallet. Not available is the status. Let's run this command one by one. So that's done. The first command has been completed. Let's now see the status. Status is closed because we just created it. We are going to open it. So the second one command is going to say open. So we are going to open. Second command is about opening the wallet. So let's do that. Succeeded. Now status was closed. Status is open but no master key. That is correct, because there is no master key. And the status is open but no master key. Let's create the master key using set key. That's done. Now let's take a look what is our status. And status is open. And let's take a look at encryption keys. And we can see we have an encryption key in our database. And finally, what we are going to do, we are going to convert this wallet to auto login. That's done. All of the 4 commands have successfully completed. And at this moment, our wallet has been successfully set up. So what we can do now, as I mentioned, we can do all of this. So we can create a table with encrypted column. We can encrypt existing column. We can create encrypted tablespace. We can convert an existing non-encrypted tablespace to encrypted tablespace. We can move a table from unencrypted tablespace to encrypted. We can enable RMAN backup encryption. So all of these things, because our wallet has been set up, we can proceed to do all of this activity. So the first thing that we will do is we'll try to create a table with encrypted column. So before doing that, let's see if we have any encrypted tables in our database. So you can see with encrypted columns. So you can see query return 0. So there are no encrypted columns. Let's run this. We have created a table, and while creating we said C2 column has to be encrypted. Now let's run this particular query. We have one column and salt is yes, because by default the salt will be yes. Let's now create another table, second table. So this is the normal table, and what we are going to do now is we are going to convert this particular column to encrypted column. So that's done, and now we should have two columns, yes and salt is equal to no, but both that there is one column in test1 C2 which is encrypted. Test2 C2, when we created it was not encrypted, but we modified it to be encrypted. One has got salt, one has got no salt, because when we converted it we said no salt. So this is how you will convert your either you will create encrypted columns, tables with encrypted columns, or you will convert an existing column from an existing table to an encrypted. Now that we have seen about the table level, let's understand about the table spaces. So how do you do that? Let's take all of this, and first we'll see what is our status. So you can see all of our table spaces encrypted is no. Let's try to create a new table space called TS encrypted, and we'll use this particular syntax. That's done. Now let's take a look at our list of table spaces, and you can see we have created one TS encrypted, and encrypted status is yes, which means using this particular clause we can create an encrypted table spaces. Now let's create a table in that encrypted table space and insert a record, and I'll tell you why I'm going to do that. So let me run all of these four things together. So we created a table, we inserted a record, we selected from that particular table. So this test is in this. If you can see, when I created, I specified which table space. So the encrypted table space. So the test table is by default. The data which is there in the test table is by default encrypted because it is present in the encrypted table space. Now let's run this particular query one more time. And you can see the user's table space is not encrypted. If you want to make it encrypted, you will say alter table space users encryption. So you will use the alter table space. So right now we are going to convert the user's table space to an encrypted table space. So now let's go back, and here user's table space was unencrypted. Now let's run this query, and we can see the user's table is now encrypted. So now we have learned how to create an encrypted table space and how to convert an existing table space to encrypted table space. Now the final part of this is take an RMAN backups, encrypted RMAN backups. Before doing that, let's see if we have any RMAN backups in our system. To do that, I'm using the $backup base. So let me set this clause. Let me take a look at this, and you can see I don't have any backups. There are no backups available in my system. So let's connect to our database as RMAN. So before doing that, let's set the environmental variable. That's good. And let's connect to our database using RMAN. And what we are going to do, we are going to take a look at RMAN configuration parameters. And here you can see configure encryption for database is off. Configure encryption for database is off, which means the backups will not be encrypted. So let's try to take a backup. And I'm going to be wrong here, and you will understand what I'm saying here. So this particular setting is off, and I'm taking a backup of the database, and I used the backup database command. So let's wait for this particular backup to complete. Give it a minute. Yeah, that looks good. Now let's take a look at the encrypted status. And you can see although this particular setting is off, although this particular setting is off, it says the backup is encrypted. I would leave that to you to identify why the backup is encrypted, even though this particular setting is off. And I'll show you what is this backup and what is this backup. So let's run this v.backup piece. This is the backup piece and this is the control file backup. So this is the control file backup, and the control file backup is not encrypted. So control file backup is not encrypted. However, the main backup piece is encrypted. So I would not answer why this happened, even though this particular setting is off. Now let's do something. Let's convert this setting to on. Connect as RMAN. Set this particular setting to on. That's done. I don't want to do you show all again. And let's run the backup database once again. So I'm taking another backup after converting this particular parameter to on. And now let's see once the backup finishes. Let's see what happens. Wait for the backup to complete. Remember that backup is encrypted. So there will be some performance impact of this. So the backup is completed. Now let's take a look at what it's saying. And here you can see now the backup piece and the control file auto backup both is encrypted. Previously, only the backup piece was encrypted. The control file was not encrypted. Now both is showing as encrypted. Sorry. And to do that, what I did, I said configure encryption for database on. So we have seen everything. Now I just want to show you the tutorial. You can skip the next part, but if you want to hang on, I want to show you something. What happens when the wallet is not present? So let's do something. Let's go back. Let's clear this. And let's pretend that somebody deleted. I'm not going to delete it. I'm just going to rename that particular wallet directory. Wherever we created the directory, I'm just going to rename it. And then what I'm going to do, I'm going to shut down the database and start the database. So the wallet is no longer present, and let's see how the database behaves. So the database is getting shut down, and then it will go for the startup. So as you can see, the database has been opened. Now what we are going to do, I'm going to go back to the SQL developer, and my connection would have got disconnected. So let me disconnect and connect, because I restarted the database. And what I'm going to do now, I'm going to try to select star from test. And here you can see security wallet was not open the wallet. So the reason for that is when our wallet is auto login wallet. So when the database starts, it should read from that wallet, but because it could not locate that particular directory, it could not locate the wallet and it did not open the wallet. So we cannot now select from the database. We cannot select from the test table, and it clearly says the wallet is not open. Let's try to do something. We created table called test1. Let's try to insert a record in this particular encrypted, because there is one column in this particular table which is encrypted. Let's try to see, and both are integer, what happens if whether we are able to encrypt. So let's say first is 1 and second column has got value of 2, and let's see if we are able to insert into an encrypt table with encrypted column. And you can see wallet is not open. So we cannot insert values, neither we can select from an encrypted table. So let's do something. Now let's rename that wallet back to the original name. We don't have to bounce the database. And what I'm going to do now, I don't have to restart the database. All that I'm going to do now is I'm going to just run this particular command. So administrator, I'm going to open the key store. We don't have to bounce the database again. So let's open the key store. That's succeeded. Now let's try to select from the test table, where we are getting the warnings. and you can see we are able to retrieve from the table which is in the encrypted table space. And here we got the warning when we try to insert, we were not able to insert, wallet is not open. Let's do that, and you can see one row inserted and we are able to successfully insert in our database. So this was the short tutorial for how to set up the wallet, how to do the, once you have set up the wallet, how to encrypt a column or encrypt a table space, how to do the RMAN backup encryption, and what happens when the wallet is not present. And this particular tutorial was done using administer key management. Now remember one thing, there are other ways to set up your wallet, and you can use Aura PKI or MK Store. I used administer key management, and in the next tutorial I will talk about Aura PKI and MK Store. I hope you like this particular tutorial. Thank you for watching. If you did like the tutorial, do subscribe to my channel and see you in next tutorial. Thank you and bye bye.